2007 and PhD degree in network engineering from Victoria University of Wellington, New Zealand in 2010. He's currently a professor with the Department of Computing and Information Systems, Sunway University. He's also a researcher, a lecturer, and a consultant in applied artificial intelligence, applied deep learning, reinforcement learning, wireless networking, and ITS. Next in our panel list is Andrea. She's research scientist and user experience designer working at A-Star Institute of Infocom Research, Singapore. Her work focuses on designing multimodal intelligent interactive systems. Some of her works are dealing with ITX, in particularly autonomous vehicles and intelligent parking application. She has a keen interest on smart cities and was part of ITS lab established in Infocom in cooperation with Continental AG. Andrea studied computer science in Germany at the Ruhr University, Bochum, and did her PhD in the Netherlands at the University of Twente. She's a passionate advocate of social empowerment, sustainability, and environmental protection through technology adoption. So now let's start the fireside chat session. We have questions to Ceylon. Ceylon, can you hear me?
Yes, I can. Thank you, Yongli.
Yeah, so Ceylon, do you think ITS is an expensive solution when developing a solution to achieve SDG, which is for sustainable cities and community? If not, can you share how developing countries can move forward with ITS by exploiting technologies such as IoT?
Thank you, Yongli, for the nice question. Yeah, I think in many developed countries, we are looking into autonomous vehicle, looking at intelligent control. These are very expensive operations. But I think for the developing countries, we are also need to take care of their needs and how can we improve their urban mobility infrastructures. So we've done quite a bit of work on how do we use IoT technology in order to improve the public transportation system in developing countries. In particular, we wanted to look at how data can be collected, and based on this data that we have, we can then further make use of AI and machine learning techniques in order to further improve the public transportation offering. So maybe I can share some of our work done in the past few years on how do we use technology to improve the urban mobility management in developing countries. Right. The outline of the talk today, or some of the stories that I plan to share with everybody today, is on how can we use IoT technology in particular in order to improve the urban mobilities for developing countries. One use case that we have trial in Malaysia is to use IoT-based technology in order to track buses, in particular the stage bus or public buses, and to share some of our deployment experience insight. And we are hoping that, based on this work, we can make some impact to the developing country and, helping people in developing countries. As we know, Internet of Things is looking at, all kinds of different sensors and devices that are connected to the internet essentially. So the internet connectivity and infrastructure is the backbone that we require in order to enable Internet of Things in the first place, right? For Internet of Things, most of these devices are connected wirelessly. We use these sensors to collect data and actuators to do trigger actions, to do some actuation on the actions itself. So based on the data collected, then we can potentially store that into the cloud or even process it at the edge, on edge devices. So we can do all kinds of processing, including AI or machine learning on cloud or on edge devices. Okay, but the problem with the processing on the sensor itself is that the sensors are typically very constrained in power and memory. So we need to be very careful on what are the data that we collected and how much processing that we need to run on these sensor devices. So essentially, we are trying to create a smart environment right, using some of the IoT technologies that's available, be it from wireless connectivity parts or from the machine learning or AI aspects, in order to replace some of these manual processes with automated and internet-based solutions. So essentially, a good Internet of Things solution should consist of a backbone internet connectivity infrastructure. Then we have the hardware devices that are being deployed, and then we have software or middleware running on the devices in order to collect data or to do actuation. And essentially, the data could also be stored or usually stored in the cloud services for further processing. And then this will also be coupled with intelligence. Based on the data, we learn about new things and insights derived from the data, and then we can further improve our applications. And of course, the internet connectivity, such as your LTE or 5G connectivities are important to enable all these IoT applications. If you look at urban mobility's scenarios or scenes in Singapore today, having a efficient tracking of your fleet informations and integrated with the information dashboard by the public bus operators are pretty standard and normal, right? So at the bus driver side, we have the dashboard for the bus driver, to look at the current traffic informations and the bus location information. And there's plenty of mobile app available for the passengers to actually check the location of the buses, the estimated time of arrival. So there are many mobile apps that's available. There's even Open Data Mall, where anybody can just grab the data from the Open API, right, and develop the mobile app to get the information of the public transit system, right? So there's a huge cooperation between the bus operators, the government authorities, right, and also the innovations companies, right, to work together in order to provide an efficient bus services. If you look at Singapore further, they are looking into, how can they actually deploy autonomous bus even in selected places such as in Sentosa or less populated area, in order to ferry passengers from one to the other. So there are trials currently running in Singapore. I think maybe Andrea can share about all this later on. This is some of the work with our collaborators that actually looking at autonomous driving in Singapore, right? So they were looking at how to enable full automation of AVs in Singapore, right, using AI and machine learning techniques. So including avoidance of obstacles, paying attention to the traffic rules, and handling junctions and all these things, right? So there are currently some trials in Singapore on autonomous vehicle. We are also working with the companies and some universities on how do we reduce the risk of collisions, when we deploy autonomous vehicle in Singapore. So in a developed countries perspective, things in public transports are pretty efficient, right? And now they are looking into a higher level of automations in order to further improve the efficiency of public transport systems. The situation in the developing countries could be very different. For example, if you look at, on the left-hand side is a picture in Kuala Lumpur, Malaysia, where you see a huge crowd waiting for the buses, and they don't even know, sometimes due to the bad traffic congestions or the unreliabilities of the bus services. It's very hard to actually know when the bus will arrive and when can they get on board the bus. Right, the right-hand side is a picture that I took when I traveled in Johor, right? There were also people waiting in on rainy days, waiting for the buses. This can be quite painful sometimes, right? So if we are able to actually improve, at least the minimal efficiency for the bus services or reliability in developing countries, I think that will tremendously improve their daily activities and commute. And if you look at the number of developing countries and least developed countries on this world map, right, you can see that a majority of these countries are actually classified as developing countries or developing economies, right? I'm sure that they may not be able to afford a very expensive or extensive solutions, right, in order to improve their public transportation system. And that's why, how can we use some kind of IoT technology in order to improve them, this public transportation system, and potentially that can make a large impact to a lot of people in the world. Some of the urban mobility challenges in developing countries that we have gathered, because we spoke to bus operators in Malaysia, for example, they were saying that most of their investments were actually on purchasing of new bus fleets, and there's less consideration on the software infrastructure. So they purchase electric buses, they purchase hydrogen buses, or they purchase hybrid buses for testing. So these are mostly the hardware infrastructures. And the reliability aspect and the software infrastructure aspect is something that is usually lacking, right? And that's also very much due to the manpower crunch, because there are lack of bus drivers due to regulatory policy. It's very hard for them to employ bus drivers in order to serve the people. In terms of the reliability aspect and the efficiency of the public bus services, for example, what we observe is that also most of the time, there's no adherence to the bus service schedule, right? The drivers could depart whenever they want, or the driver could wait until the bus is completely filled before they depart from the bus station, for example, right? So the other problem is that sometimes the driver can also call in sick, and then the bus services could be disrupted, especially those serving in the rural area. So if you don't have all this information on hand, for the passengers to know, right, then they may just be perpetually waiting for the buses to come, which eventually did not come, right? So what we actually did is to look at what are the ways that we can potentially do in order to improve the public bus services in Malaysia, for example. I personally from Malaysia, so I live in Johor. So what I did and what my students and I together did was, the bus operator in Kulai in Malaysia, right? And we look at, how can we improve the service offering, aiming to provide some kind of fleet tracking and bus arrival information to passenger in a low-cost manner. Okay, so the first version is that we thought that it's very easy, it can be easily done. So for example, you can use in GPS devices. You just install it on the bus itself, and then you implement some data processing algorithm in the cloud, and just develop mobile app. I think that pretty much solved the problems, right? But in order to do this, then there will be some kind of investment required in order to install all these GPS devices. You may also need 4G connectivity in order to get the data. So in order to do this, it will come at a cost, which most of the bus operators may not see that as a huge investment with a great return of investment, right? So the first idea that we came about is to actually look at how can we use, maybe we can use some sort of crowdsourcing, because waste is pretty successful. So we thought that we can potentially use crowdsourcing, relying on passengers to supply some kind of data or information on the bus location, right, in order to first improve the efficiency of the bus services. So the idea was very simple. So we just hope that at least one passenger per bus is willing to share the bus information using their mobile phones, GPS location throughout the journey. Then we're done, right? And Malaysians used to be pretty helpful, right? So we have this kampong spirit that we want to help each other. So this is idea that we came about taking into the examples of waste. Because we don't want to have any additional costs incurred to the bus operator, and we also don't want to also purchase any hardware or 3G connectivity for the operators as well, right? But then the question, of course, it comes to how can we incentivize the passenger to use the app, and share their location, because essentially we are using that data in order to share the location information. So first architecture was a pretty simple implementation that we developed a mobile app, right? And then we encourage the passengers to actually share their bus location while they are on board the bus. So the location was pretty frequently sent to our cloud services to do some simple data analytics and calculation of bus arrival time. right? So based on the the bus speeds and the distance and all this information, we will be able to provide some kind of estimation of time arrival for the passengers waiting at the bus stops further down the route. We also did some promotion and marketing, in order to encourage passengers to share information. We have a template, to actually teach the users how to use this, how to scan the QR code, how to share their location information, right? And we did a trial and employment for 3 to 4 months. So we stick a QR code on at the back of the bus seat, right, together with the flyers, teaching the passengers on how to use this mobile app development, right? So at one point that we wanted, passengers to provide us with the data, but at the same time also wanted to provide some convenience to the passengers as well, right? We even provided some further functionality for the passengers to track their arrival time, right? So that, in Malaysia, because typically for the last mile connectivity, you require your maybe your family members or friend to pick you up. So it's not easy, right? So they could actually scan the QR code using their mobile phone, and then that will actually inform them of their arrival time at the destination. And then they can then send a WhatsApp or a SMS message to their family members to pick them up at the bus station, right? So that was a way to incentivize the passengers to use the mobile app. So at the same time, they are sending us the location data in order to help with the estimation of time arrival. But the problem with this crowdsourced information is that it's pretty difficult, because due to the human behavior that we also observe, after maybe 2 weeks, then you see all the QR code have gone missing. So we had to replace them like every 2 weeks. Most of the people were also not really bothered about the kampong spirit to help each other or to share their information. Even sometimes we also actually ask the bus driver, maybe the bus driver can actually use the app, then we don't have to rely on the passengers to share information. But even the bus driver were not willing to do that, right? So there goes the first version of it, where the version 1.0 wasn't successful, and without a way to really incentivize them, it's really difficult, right? Then we came to the second approach, where maybe we can take the human out of the loop, right? By doing some kind of automation, right? Maybe use some of the IoT technologies that we can, but still with a low cost mindset, right? What we did try to do in the second version here is that we use the Raspberry Pi devices that are able to do Bluetooth proximity detections, right? We also use or deploy a Bluetooth low end on buses, so that it periodically emits signals, right? So when the bus approaching the bus stops, then we will know that the bus has arrived and the bus real-time location. So of course we retain the cloud platform for the data analysis. So the architecture is pretty much the same in a way that we still have devices deployed in the bus itself, right? Instead of relying on passenger, now we deploy a Bluetooth beacon inside the bus, right? And this beacon will emit Bluetooth signals periodically, and we then deploy a Raspberry Pi devices along the bus stop, along the routes. This Raspberry Pi devices is equipped with internet connectivity, and also it has the Bluetooth that is able to detect when the bus is in close proximity to the bus stop, right? Then it will detect the signals from the beacons, and then we know that the bus has approached the bus station. So once it's detected, we send the location data to the cloud for analytics. Okay, in this way, we don't have to spend money on equipping all the bus with 3G connectivity, right? So we just have to have the internet connectivity along the bus route to the bus stops, and then we can still get some kind of location information, though it's not really real time, right? We then revamp our mobile apps, to allow for deployment or download from iOS and Android devices. Okay, and this is a typical field trial deployment in a bus stop, right? We have our Raspberry Pi devices deployed here, because we need to power the Raspberry Pi devices. So we actually rented the power sockets from the store owner, right, to power our Raspberry Pi devices, which has to be to run 24 hours, 24/7. Then we have internet connectivities, and then we have the mobile apps for the passengers to use. Okay, from the accuracy perspective, normal situation, we have accuracy up to plus minus 3 minutes, non-congested congested time. So we actually deployed a few of these Raspberry Pi devices along the route in order to provide bus location information, right? So we spoke to some of the store owner, and some of the bus stop, they did not have a power socket, so we had to actually speak to the restaurants or some of the shops nearby in order to install our devices. Okay. We also evaluated some of the reliabilities and transmission range issues. So if you look at the Bluetooth proximity detection, it's pretty much accurate, with different range of transmission power and also the speeds of the buses that's running, right? So sometimes the bus can run very fast, but the Raspberry Pi devices were still able to detect the bus instance. So that's pretty much reliable. So we actually deployed it for about 1 year for this solution in order to gather data on the bus location information, so that we wanted to do further work on the data that we have obtained, right? So the next thing that we wanted to do is actually to look at, based on the data that we've collected from the devices, right? We wanted to then look at, can we use some kind of machine learning techniques in order to do some predictive analytics, based on the data that we have, because we can look the driver's driving profiles, the driver's patents, and also the arrival timing, and then we can also possibly derive, whether there's any traffic congestion, the journey time between the stops, etc. Right. On the Pi devices itself, we are also in the process of looking at, can we look at the Wi-Fi signals that we gathered along the around the bus stop itself, right, in order to try to derive how many users are in the areas. And then with that, we wanted to look at how can we estimate the crowd level at the bus stop, and this information can further be fed into the bus operator, so that they know there are many people waiting at the bus stops. So some preliminary work had been done on bus arrival predictions based on the data collected. We made use of some AI technology, on the data sets that we collected. So we also obtained the raw GPS data set from the bus operators, because this raw GPS data set could not be used for us in real time, but historical GPS data were obtained, from the bus operators, only some of them. And then together with our location data, we did some cleaning and planning, right? And then we fed into some TensorFlow machine learning models in order to do some kind of predictive of the arrival time. So in a way, I think, once we have collected all this data, I think then the next stage is to look at how machine learning technique or AI technology can actually make it more efficient and make it more useful, which I think the other two speakers will share more about the use of AI techniques for this. From our deployment, we also realized that, in order to deploy solutions, right, even though it might be well thought through, but there might be a lot of other issues or challenges that we need to overcome. For example, we have human behavior issues, we have beacons being stolen, we have Raspberry Pi is gone, or the SD card is gone, we have power being unplugged, internet connectivity is unreliable, and all this. So we hope that, by using technology and automation, we can really help to develop the public transportation system and make it better in the developing countries. These are some of our students who work on this project, so I would like to thank them for their contributions. And I think that's all I have for today. So if you have any questions, or if you are interested in the solution and you want to work together, feel free to contact me. Thank you.
Wow, that is a very great initiative that you're working on, Sei Long.
Thank you.
So we can see that it's a game changer for developing countries to adopt technologies in creating inclusive cities, especially when the world continue to urbanize. And 96% of urban growth will actually occur in less developed regions of South Asia, Southeast Asia, and also Africa. So one of the pressing issues with developing countries is actually the traffic management. Yeah. The rising traffic congestion in cities is curbing economic growth, especially increasing the greenhouse gas emission and impacting the citizens' quality of life, especially in Malaysia when there are an average of 2 cars per household. So the next question is for you, Kok Lim. Can you share your thoughts on how we can use machine learning-based systems to overcome the problem of traffic congestion in cities, especially in developing countries like Malaysia?
Hello, everyone. A very good afternoon to everyone. And I'm Yao, and it's very good opportunity from Dr. Chung, and it's basically Dr. Shah has shared with us about the IoT. I think it's good to explore how actually AI can help us to solve the problem. Okay, allow me to share my slides. Okay. Okay, so basically, what I'm going to present today is how deep reinforcement learning are used to solve the traffic signal control problem. So I'm going to focus more on the AI part because it's going to be one of the most recent technology to solve problems in intelligent transportation systems. And deep reinforcement learning is something I've been working on. In fact, I started research in reinforcement learning like 10 years ago when we only look at reinforcement learning. And only recently, I think in year 2016, when deep reinforcement learning, won the chess game against the world champion. And that actually gave me a great insight about why not we develop system that can make our intelligent transportation systems to become smarter, or one day it can be smarter than human. And how can we do this? And this is a pressing questions in my mind. And that's lead me to actually look into these questions. How we can apply the deep reinforcement learning to improve intelligent transportation system, and particularly I'm looking at the traffic signal control. Now, why are we looking at this traffic signal control? Wow, the traffic intersections have been signalized for decades. Well, the main questions here is that we know that traffic signal control it has been there for long, but it has been quite deterministic all this while. And we know that in next generation, the traffic signal control is going to play a significant role. And it's not just like trying to control the traffic. It can have so many other functions and features that are yet to be explored. And the very first thing that we want is, can we use deep reinforcement learning to control the traffic signal control and to make it smart enough, as a start, it start to manage the traffic, the traditional task that it's been doing, and how about we can use it to do something else, which are more advanced in the future. So it can basically, for example, notifies the cars at the intersections when the ambulance is arriving, or when accidents is happening, so it can actually inform the other cars and take precautions or take other actions. So many things can actually be done with a AI-enabled traffic signal control. So let's take a look at how we actually use this deep reinforcement learning in this case here. All right. Okay. So So we use reinforcement learning, and it's basically one of the approaches that is rather different compared to the yesterday's approach like the supervised learning. So in supervised learning, you basically require the inputs, and you basically need to label the inputs, and then you train the AI approach, and it provides the output. But with reinforcement learning, you don't need to label the inputs. You essentially, allow this AI to learn, on the fly. So it can actually learn from the operating environment itself and yet produce very good outputs. So how does it work then? So we're going to see how we actually use reinforcement learning to solve problem. And I know it's kind of like complex and complicated, but let us simplify it and think how we can actually use it in this case. Now, one of the first decisions made in life is how many steps do I climb, like the decisions made by the baby or toddler. And if you're at home, maybe the toddler climbs 5 steps, and it's brilliant, So mommy then scold the toddler. Well, maybe the mommy afraid that the toddler will have a fall, and so it's not good to climb too much. So 5 steps could be good, and so it's great. And the toddler learns that hey, climbing 5 steps is good. But now it's at childcare, and the toddler climbs 5 steps again. And you know what? Anyone can do better than this. And that actually doesn't seem like there are any special skills that the toddler can be proud of. So, that's what we call the peer pressure, right? And now the toddler learned this knowledge. At home, I climb 5 steps. At school, I climb more than 5 steps. And now I'm at childcare again. Let's climb 10 steps. And at this point of time, he gets reward from its peers. So we can see that, you don't need to actually label the data in order to learn. You can actually learn from the environment by knowing the reward or the punishments or the negative reward or the cause from the environment. Now, therefore, I always share this, make it clear that reinforcement learning is easy to understand because it's just an if then else statement that changes as time goes by. So if the toddler, under circumstances, he should take just action one. At home, the toddler should climb 5 steps. At school or childcare, maybe 10 steps. So the toddler can't be climbing 5 or 10 steps forever, right? So the toddler grows, and so different actions need to be taken as the toddler grows. So the type of actions to be taken change as time goes by. And so the if then else statements tend to change. And reinforcement learning is just as simple as a dynamic if then else statement. And there are more advanced reinforcement learning approaches. For example, the multi-agent approach, whereby you can see that there are actually 2 agents, all right, agent 1 and agent 2. So both of them are learning with each other. They actually exchange the knowledge among themselves. And that approach is more advanced, and yet it's actually more efficient when you have more than one decision makers in the environment, okay, whereby both of them can actually learn from each other. And so the advantage of the multi-agent approach is that you can actually segregate a very complex problem into distributed problem, whereby each agent will, or the decision maker will take a sub-problem and solve it. And this makes the problem easier to solve, and it actually can help to address the curse of dimensionality, which means that the problems can be simplified. So you have lower computation costs, lower learning time, and smaller storage capacity required. Now, what we use today in our work is the deep queue network. And the deep queue network is the deep learning approach. It basically marries the deep learning and the reinforcement learning approaches together to provide you a more advanced approach. So it basically uses the deep neural network, and the advantage is that you can actually store the different kinds of environment or the state and the actions in a more efficient manner. And this helps to lower the computational cost. It reduces the learning time and also reduces the short storage capacity. And there are two features, which are experience, reply, and target network, which I'm not going to explain here, but if you want to know more about it, so do contact me or let me know after the presentations. So this is basically the deep neural network architecture that we use in our experiment later. And we actually conduct a case study, look at the Bandar Sunway in where and you can see that the traffic here is really massive. Why? Because there are two universities here, okay, the Sunway University and and apartments center. And there is a similar good. Not sure if you know about this. This is very well known for its water activities. There are hotels, so it's a tourist spot as well. So you can see that it's very vibrant, but there are 5 traffic lights along this main road. And the traffic should be smooth at all times because you have a center here. Unfortunately, this road is well known for its heavy traffic as well. And to solve this problem, we basically capture the traffic lights. We try to understand how the traffic lights works, and we try to understand the traffic situation. And we use the multi-agents deep queue network approach. So we enhance the deep queue network, which is the traditional deep learning, reinforcement learning approach. We enhance it. We allow the multi approach for this deep network approach. All right. And we embed this multi-agents DQN approach in the 7 intersections in the Sunway City to control the traffic signal control. So how do we control? We basically control the traffic phases and the traffic phase split. The traffic phase split is the durations for the traffic phase. Okay? Each phase is a set of green lights without conflicting or without conflicting the traffic. All right. So the purpose is to increase the throughput and reduce the average queue length and to reduce the average waiting time during the peak hours and rainy weathers. Now, take a look at the situations whereby the picture shows the rain and when it's raining, the traffic is really horrendous. So we want to solve this problem here. So objective is again to control the traffic signal control, all right? And the operating environment is dynamic. Why? Because the traffic is dynamic during the peak hours and the rainy day, whether it rains or not, and when it rains, the dynamicity of the traffic is also a problem. And the industry actually came back to us and told us that, even though we have this camera and during rainy day, the camera may not be able to capture the picture accurately, and so the traffic conditions can be quite difficult to capture at times. So that is one of the problems that we actually have got from the industry. And you can see that we actually focuses on the bad weather. Why bad weather? Because if it doesn't work during the bad weather, then if it works during bad weather, it works during normal time or when it is not raining. So we focus on the worst case when there is a rain. All right. So we feed all these informations into our AI, and then we produce the output. Okay. And we have these 7 intersections in Bandar Sunway. And we actually also go to the intersections and we actually take a look at how the traffic phase splits actually are determined. Are there any intelligence at the current traffic lights? Actually, the answers came back as quite negative because we found that the traffic phase splits are actually quite the same for most of the times, even during the peak hours. So we believe that something can be done more on this. So these are our simulations parameters. We actually focus on the queue length, the waiting time, and the throughput. And then we measure the multi-agents deep reinforcement learning work, and we show that it can achieve a better reward, higher throughput compared to the deterministic and also the traditional reinforcement learning and the multi-agent reinforcement learning approaches. And it also is able to reduce the queue length and to reduce the waiting time. Okay, so that's basically a very introductory descriptions about what we have been working on, and we have been liaising with industry to deploy what we have been working on here. And there are a lot of issues that we want to solve as well, because in the simulations, we can actually make decisions based on some of the valuable information that we can get from the simulator, but in reality, we cannot get those informations. For example, the current traffic phases, the current traffic phase plates, the other scenario, the other circumstances like accidents, maintenance, road maintenance, and so on, particular accidents. We can't be creating an accident to make our artificial intelligence learn, because this is, some things that we can't learn. So how to learn in the situations whereby there are accidents or there are some very distinguishing circumstances, so all this require further investigations. So if you're interested in this work, so do let me know, and we can actually discuss further about this. Thank you.
Okay, thanks, Tim. Thanks for sharing the projects that you have been doing in Bandar Seri. I remember the traffic that is horrible, especially during like peak hour. It can take you like hours just to reach a very short distance. Yeah, so that's a very good initiative to integrate AI in traffic management to reduce the problem of traffic congestion, and you integrate in the traffic light systems. So yeah, I have a questions for Andrea. So based on your experience as research scientist and user experience designer, what is users' perspective on technology adoption to decrease emission, fuel consumption, and also traffic congestion here?
Yeah, it's a very complex question, and it involves many factors, especially if we talk about new technologies, like, for example, autonomous vehicles, right? I will try with my presentation to answer to your question, but just to give a brief answer, when we look at users, and when we say user, we mean citizens, right? Citizens are actually economic agents, and they have an very opportunistic behavior. So actually, my previous speaker, Silong, was saying before, it is very difficult to motivate people to use something, and people will use it if they see a perceived benefit in using it. Of course, when we talk about fuel consumptions and traffic congestion, of course, no one wants to spend waste money or spend countless hours on the roads, right? But when we think about decreasing emission, right, and protecting the environment, people tend to have an individualistic behavior, and things actually needs to be a bit educated from the childhood. So that's why it's important that actually a policymaker look at the education of the people, as long as they look at and how to develop a very good infrastructure of the city. Let me start sharing my presentation. Let me see how to do it. How can I share? I'm allowed to share?
Yes, you should be able to share.
Yes. Yes, okay.
Yeah.
So, yes, because I'm also living in Singapore, so I can speak from experience. So when we talk about intelligent transportation system in Singapore, actually Singapore is an absolutely wonderful example. It's a pioneer country. It is the first country to have a smart nation minister that was appointed in 2014. Just a second. And it's also very interesting because it was the first country to introduce an electronic price systems in 1998 to monitor the traffic flow. And the government continues to invest billions of dollars yearly into intelligent transportation systems so that the land transportation authority can build all these kind of wonderful infrastructures of roads and to develop all these very good public transportation system. McKinsey was actually naming the public transportation in Singapore as the best in the world. And I can say I live here, and it's indeed absolutely amazing how the most remote corner in the island is connected with the downtown, and in 20 minutes you can reach it from any corner, the downtown. And of course, having a very nice network infrastructure. So we have here, I think, 160 kilometers of express roads and more than 9,000 long kilometers of roads, very well developed. The city infrastructure is one part of the equation. The other part is developing a high-speed internet infrastructure so that all these thousands of gadgets on a sensor and cameras that are attached to the road infrastructure can be connected and can send a fast amount of information, because this is what actually the smart city is about, that it connects people with the city and it creates a more using this data that is generated from all these gadgets. It can be used to decrease emission, to have a more efficient transportation system, and it can also connect the citizens with the city. So, and here are a couple of examples that I found interesting in Singapore. Of course, they are not unique to Singapore. They can be found in other cities as well. Some are meant, for example, to decongest the traffic by informing about accidents, road closure, traffic conditions, so that drivers can make plan the journey much better. Some applications, for example, are used to switch the traffic light to green, so the drivers can just pass when there are no pedestrians. And of course, there is one application which I found it particularly interesting, and I haven't seen it in other places. It's called the Greenman Plus. It's basically senior citizen. They can receive a special concession card, and they can use it to tap it and increase actually their traffic when crossing the time when crossing the pedestrian. They can increase the time so that they can take longer to cross. And of course, there are also applications increasing the sustainability, like increasing the mobility of the people. These are bikes and electric car sharing options that can be found in Singapore almost everywhere in near the MRT and bus stops. There is this company called Blue SG, it's a Singaporean company that is extremely successful. It's actually the second largest company of electric cars, sustainable cars. And they started, I think, maybe 3 years ago. And within 3 years, they started with, I think, 80 cars and 30 charging stations. And right now they have like 1,400 plus charging stations and almost 700 cars. So it's amazing for the development. And I think Singapore is one of the best prepared cities. It's one of the best smart cities actually, and the best city to actually introduce a more advanced intelligent transportation system like autonomous vehicles. So in my presentation, I'm going to present 2 case studies I worked on. The first one is a parking guidance application. It's intelligent driving assistant. And the second one, it's a study that we did on the autonomous vehicle. So you might ask, I mean, because Singapore has such a nice infrastructure of roads and the traffic is so smooth, why do we need actually a parking application? And indeed, the roads are extremely well developed, but Singapore during peak hours is confronted with actually quite heavy traffic. And there are actually not really information, clear and timely information about parking spaces. So it makes sense to develop such applications also for Singapore. And there is also a very interesting research that shows that actually 30% of the vehicles on the roads in downtown areas are searching for a parking place. So 30% of these vehicles that you can find in downtown, they are looking for a parking place. They are not just transiting. And they spend in average about 7.8 minutes to find one. So you can imagine that how much the traffic is actually increased. So this is one of our first prototypes that we developed during this project, and it's an intelligent driving assistant that actually uses speech and natural language to communicate with the driver. So because this is a more safe option, so people do not need to actually input, they can use speech to input and receive answers also in form of speech. There was also a possibility for the application to actually read the calendar of the driver and actually find out the destination by itself, and actually propose certain car parks based on the price and on the I think this distance to the proximity to the place where the person wants to go. And I think the idea of this intelligent driver assistant is actually more sustainable compared to other parking applications because it does not actually reserve a parking spot. Many of the parking guidance application I have seen, they can use actually option to reserve a parking place. But that's exactly what actually we should not do because we will keep their spots actually occupied while other cars will keep searching for a parking place. So it's in terms of sustainability, this might not be a good option. And also we worked with the Land Transportation Authority delivered us the data that was actually from the car parking places. So we could actually find out how the spots were, how the parking places were occupied during the week. And based on this information, we could do a prediction so that the driver who was arriving at the destination could actually have a prediction how the parking spots were looking, what is the possibility to find parking spaces in the parking place of his choice. Also because when you drive using speech, it's a bit. I mean, you need usually for speech recognition you need a microphone, and microphones are actually capturing the whole noise in the environment, and this can be very sensitive for the application. And therefore, we actually came up with the idea of a push-to-talk button that was actually placed on the wheel. And the driver could actually press on the button in the moment he wanted to input something. This is actually one of the prototypes we worked on. So certain features in the final product, certain features were removed, certain feature was added. It has quite some downloads, but because we talk about the technology adoptions, I believe we are going to see what's going to happen over the years with application, but I believe the most important thing is actually how people perceive the use of this application. So if they consider that the application is actually user-friendly, if it has enough information available, because that was one of the things that if the application offers a lot of parking places because people want to go everywhere on the island, but if the application does not offer information on different parking places, this might be a bottleneck. Also, the system performance, you want something that does not have crashes, right? The information also has to be accurate, so it has to be always updated, and it has to be available also on different platforms. That is also one of something that the designer and also engineers have to take into account. And in the end, if people realize that using this app, they're going to save cost, it's very likely that they will probably use the application. So the second study I was about to present, it's about autonomous vehicle. As Shilong was actually mentioning before, Singapore is planning to introduce autonomous driverless bus by 2022. And of course, I don't think that there is any other better city in the world as Singapore to introduce driverless buses, because it has these absolutely wonderful transportation systems, and it's very well equipped as a smart city. But the question that we asked as designers and also engineers in my department is, okay, maybe the technology is ready, but what about the citizens? Are people also ready to drive an autonomous vehicle? So we actually, during this project that was actually a several years project, we conducted many user studies. And it's very interesting because in one of them, we invited people to our lab, and we wanted actually to give us some input on how they would like to have the user experience designed for them. So we offer them the possibility to be part of the design. So we invited around 29 people. I think there were, yeah. So, oh, sorry. So there were 29 participants. These 29 participants, we try to select people from different backgrounds, different age groups, different living lifestyles, right? We had families, we had teenagers, we had researchers, we have people with ages from 1 to 56. 61 were male, 39 were females, and we had sessions in with 3 to 5 people. Between 1 and 3 hours, and the study took us about 7 days to complete. We wanted them to actually give us an idea on how they would like to actually experience a drive in the autonomous car. But we also wanted to know what actually they think about the autonomous vehicle, what needs they have, and how can we translate these needs into user requirements, because this is very important when you start planning something. You have to have a list of requirements and see how you translate these requirements into engineering ability. So these are some pictures from our studies. So you can see in the background, we set up the lab in such way so that people can actually experience the drive in an autonomous car. There were big screens where people were driving in these cars, and that was actually our approach on how to make them experience the autonomous vehicle, because unfortunately the autonomous vehicle is we cannot bring people in the car, so we don't have the license to bring people on the road. And on the other side, we have to design the experience inside the car. So there is a trade-off that we had to find. So so we set up the lab in this way, projecting these videos on these large screens. And then we had these discussions with them while we asked them to draw their own ideas about the user experience in the car. And it was very interesting because we had very extensive rounds of discussions. And then what it came out is that we made a list of user requirements. But all these requirements were actually expressing something that actually we did not, we expected that people might be reluctant to try a new technology, but all everything that they expressed, they were all concerns about safety. There were fears about being actually trapped in the car, or having to deal with a very complex interaction style with the vehicle. And that's very interesting because we showed them the original designs that we have, And actually the designs were rated very high. So it, in our opinion, is probably it's a psychological effect that people have because they are dealing with something they don't know, it's something new. And they're of course concerned about safety. So you can see here the user experience aspects and the requirements. I'm going to focus actually on two of them because they were actually the most discussed. And one was the proven ability to cope with human sabotage, because one of the questions was, okay, we're using autonomous vehicle. We're using, I mean, everything. It's actually we're using an internet connection basically to drive this car. It's driverless. Everything is programmed. But what happens if there is human sabotage? If someone wants to kidnap the bus, probably this is not going to happen in Singapore. But what if this happens in another place? And another aspect is what happens if there is an accident. Who is going to be responsible? It's going to be responsible the engineer who maybe deleted something by mistake. Is going to be the company is going to be legally responsible. How the insurance is going to act in these kind of cases. So this was actually, there were questions that we didn't know how to respond. And I think these are also things that needs to be actually decided and established at the policymaker level, because autonomous vehicle, it's a very different technology as compared with a park guiding application. It's something that can be potentially dangerous. And this kind of legal aspects needs to be actually very well described, very well established before this technology can be put on the market. So our conclusion was that generally there was kind of a mistrust towards the autonomous vehicle that actually connected to all the requirements people mentioned during the discussions. And as I said, we were expecting this because it's natural. It's a psychological phenomenon to be a bit careful and maybe reject something that is new and that is that you never tried before. But on the other side, this mistrust can be really a handicap if we want to bring the autonomous vehicle to a commercial success, right? So, and it's very important for the designers because passengers, this is absolutely a fundamental thing. They need to be actually aware of the car reliability, and designers needs to communicate the fact that the car is reliable in a way that people can understand. So while technology is probably ready, people might take a while until they will be able to be ready to accept the technology, especially when we talk about a technology that is perceived as being potentially dangerous. So these are actually the conclusion of my talk. So depends, of course, the technology can be adopted, but it depends, of course, on the type of the technology. If it's something like a parking guidance application, probably the level of safety it's very low. It's not comparable to autonomous vehicle. It depends a lot on how these devices are designed. So the design is actually very important to facilitate and promote the technology adoption. Also, it depends on the willingness of the individual to protect the environment, because if people are conscious, okay, using this kind of technology will help us to have a better environment, to be more sustainable, then the attitude of the people will also promote this technology acceptance. And of course, we need a good smart city infrastructure and reliable hardware and software designed by professional designers and engineers. And also we need a clarification of all these legal aspects by the policymakers. So this is something I think was discussed in the first, like 1 month ago by one of the speakers. That was something that actually it's seldom discussed when we talk about autonomous vehicle, but it's actually of fundamental importance. So that is all on my side. Thank you very much.
Okay, thanks, Andrea. Yeah. So based on your presentation, Andrea,
Yes,
I do have a question.
sure.
So do you think like strategic partnership with the civil societies is important in moving the technology forward, when they have the skills to evaluate the sustainability of AI and also understand the risks? Do you think that is important?
Yes, I definitely think it is important because, as I said, it's a matter of perspective. As long as I don't understand something, I'm not willing to accept it, right? So, but there, if the social society it's educated, if there are initiatives from the society, from the social society, from the policymaker, to explain people, okay, we do this because there is it's a common benefit for all of us. As I said, people tend to be individualistic, and then as long as there is a benefit that is perceived to save money or save costs, of course they will probably accept the technology, especially if it has a good design that it's not failing or something. But for more complex things like autonomous vehicle, I guess this might take a while, and it also has, as I said, a legal component that needs to be solved before the technology can be brought in the cities.
Okay, thanks, Andrea. Sarah, what about your thoughts? Because you have developed your applications, your IoT solutions. So how do you foresee the strategic partnerships with the civil society?
I think definitely it's very important because no man is an island, so you can't really do things by yourself. I mean, we have the technologies ready, but we need to really work with the different stakeholders in order to push this technology to the people. And I think Andre was also saying that whether technology is ready and whether the human beings are ready, I think it also takes some time and really efforts, and we need to really get a lot of people to work together and look at, for example, the user studies, what are the things that can be improved further so that in order to ensure user acceptance and wider deployment.
Okay, thanks. So the next question I have is for Colin. Basically, integration of AI into various systems is actually very complex. So is there a way to provide better solutions capability for the continuously increasing complexity? Because when the system becomes very complex, sometimes user may be also very worried as well, especially in terms of the security and etc. Yeah.
Yeah. So I think this is a questions about the trustability between we human and the machines. So whether we trust the machines or not in making the decisions. Well, this is a very complex question. Why? Because the decisions made by AI is normally unexplainable. Okay, if you ask the questions like how the AI actually make the decisions, is equivalent to we ask our brain, we ask ourselves how our brain actually come up with the decisions. So it's a very rare questions we ask, right? How our brain actually come up with the decisions. So we don't ask these questions. So likewise, we don't ask the questions like this to machine, like how the machines arrive to this answer. But the point here is we do want to know, we do want to know because because if you don't know how the actually answers are being derived, how the machines make decisions, then the trust between a human and AI becomes very low. So it's very difficult for us to trust the decisions made. So that leads to the area in which a lot of researchers actually investigate into how we can actually explain the decisions made by the AI. If the decisions made can't be traced, then we ask the questions: how trustable are the data and inputs to the AI? So if you pull in some unreliable data, then you get unreliable outcomes. So to ensure that the inputs are reliable will help to improve the trustability between we and machines. Of course, to do as the AI becomes more and more complex, it becomes more and more difficult to handle this. But I mean, as long as we ensure that the inputs are reliable, that would actually help to improve the trustability. But of course, there are a lot to be done to improve the explainability of the AI aspects. Yeah, thank you.
Okay, thanks, Colin. Okay, we have another question, which I think is addressed to Andrea. Basically, does the systems that that you see in Singapore on autonomous vehicle, does it automatically recharge or go back to a charging point at this moment?
The BUSG, right?
Yeah.
Yes, actually there are different charging stations, and you are not required to bring the car from the place you are renting it. So basically you can go from point A to B, and then at the point B, you probably will have a charging station. You leave the car there, and you actually, you can go wherever you like, and you return and then take back the car and go wherever you like, or another car. So basically you are charged only for the kilometers that you are driving, and you can leave the car wherever you want. If the car is charged, maybe you can put it on a parking place. If it's not charged, you can look for a charging station near the place you want to go. But I think there are 1,400 plus charging stations in on the whole island. So and especially in spots where people like to go. So it's pretty convenient. Of course, it can be further developed. I think there are 670 or something like that. The latest, I think, what I read. Of course, it can be more than that, but it's a very good start. And as I said, this is the second biggest electric car sharing company in the world, and it's a Singaporean one. So it's actually a national proud. So yeah. It's a very sustainable design, actually, that you don't need to, I mean, to bring the car back, and then you can go just point A to B, and that's it. So you don't need to bring the car back if you don't want. You can go back by public transportation or by bus or whatever. So, yeah.
Okay, thanks, Andrea. Okay, we have another questions. Maybe Colin, you can answer this. How does the recent development of ambient computing plays into the idea for AI-based traffic control and automation in vehicles? Yeah, so start off.
Sorry, can you repeat your last word? Sorry.
How does the recent development of ambient computing play into the idea for AI-based traffic control and automation in vehicles?
I think there are a lot that to explore in this aspect, because the traffic lights seems to be like working among themselves. You know, the traffic light are it's a system separated from intelligence vehicle. So the collaborations between the intelligence vehicles and the traffic lights would help to open up more doors for other kinds of applications and services. Well, at this point of time, making the traffic lights to becomes more intelligent is a challenge here. I'm not sure how it goes in Singapore or other places, but when I liaise with the industry, so we are actually trying the data that we have got at this point of time are mostly the traffic data, which means the data for you to know the performance of the traffic network. For example, the number of cars crossing the intersections, or the queue length during the peak hours. So all these are important for you to measure the performance. But the data for the traffic lights to make intelligent decisions are essentially still lacking. And for example, we may have some camera deployed at the traffic light, but the camera may not be able to function well and may not be able to capture the scenario well, particularly during rainy days or when there is a lot of disturbances. So therefore, how to actually gather the information correctly, how to make full use of these informations for the traffic light to make decisions is actually very important. Of course, a lot of people have been talking about, hey, big data, we have a lot of data, but are those data important for the traffic lights to make decisions? So let's take another example. So the cars arriving at the traffic lights. So I mean, what is the traffic conditions? So this is also another things for the traffic systems to actually measure. But again, this is not available, not readily available. So there's actually a gap between the data that we have and also the data that we can gather and the data that we need. So to make this entire system workable, we need to gather the right data and learn the right information in order to. Yeah, thank you.
Okay, thanks. Okay, I have a last question for three of you. How do you think pandemic like the recent COVID-19 can impact the deployment of AI? Anyone wants to start off first?
Can I start first?
Can?
Okay. We are studying to understand the importance of AI, and AI is not alone. It's not about machine only. It's about the collaborations between machines and humans. And we humans tend to think that this machines is going to replace the human. Right? There are a lot of COVID-19 cases in the factory or manufacturing plants. Why not we replace all the workers with the machines? You know, so this actually came to our mind. But when you actually try to take a look at how the AI actually works and the shortcoming of AI, then you will tend to understand that we actually need collaborations between human and AI. Let's take an example. So AI as is considered a weak AI, which means that it only can perform very specific tasks given particular set of data. It can only perform very limited tasks, very specialized tasks. It is not as versatile and as flexible as we human is. So there will be a lot more collaborations between AI and human to solve more problems in the future. So we do not need to afraid that AI is going to replace human, like autonomous vehicle. Do we replace the drivers? So they have already mentioned there are a lot of issues there, whereby human is still very important. So let's work together between human and machines so that we can actually come up with better solutions. Thank you.
Okay, thanks, Colin. Yeah, Andrea, you want to add on?
Yeah, I totally agree with Colin because I'm actually something that I'm facing very often in talking with my family and friends who are not in the area of I mean they have maybe they're not so technical, they don't really understand how actually AI works. And then recently I think I got an email from a friend showing me like it was a Boston Dynamics, some robots that were able to actually hit back a researcher once they were felt like they were abused, which is a very human-like behavior. And then I think that it's very important that we actually bring about maybe AI education as we want to do like smart environment education and environmental education for the people, so that those fears of robots and AI is going to take over. It's not going to happen. AI has really some limitation, and that's why people have also some concerns when we're talking about autonomous vehicle, right? But we are far from being actually to face the danger of being taken over by machines. So I do believe it would be good that people are a bit educated in this area, so that such mistakes and such fears do not occur.
Okay, thanks, Andrea. Silo?
Yeah, I think with the pandemic, we have to keep our distance from each other, so we have to practice social distancing. Yeah, there are a lot of things that we cannot do. And so I think AI and robots are actually important, in such a situation where, they can also carry on some of our tasks at this difficult times. But I think Kotlin was also mentioning that, it's very important to understand, not just treating AI as a black box. We need to understand what AI and how the decision is being made by AI, so that we better understand, what are the things that we can delegate to AI to do, and for more higher level knowledge-based decision that we still require humans to do, right? So we really have to understand AI better and how human and AI can work together better.
Okay, thanks, Sarah. Okay, thank you very much to all the panelists and also the attendees. So we hope you will continue to join our session, the AISC Network session. We have a AISC Network members meet up next month on 15th of April at 3 p.m. Malaysia time. You can register by scanning the QR code shown here. And last but not least, we wish everyone happy International Women's Day today, and see you again and have a blessed day ahead. Thank you very much. Thank you. Take care and bye-bye.
Thank you. Bye-bye.
Thank you very much. Thank you very much. Bye-bye.
Thank you. Bye.